In this video, we're going to look at multiplying polynomials. In particular, we're going to look at multiplying two binomials, like in these first two problems, and also multiplying a binomial by a trinomial, like in these two examples. Now, not everybody likes to multiply polynomials the same way, so we're going to actually look at three different methods. We're going to multiply polynomials using box diagrams, and we will multiply polynomials using the distributive property, often called FOIL. And we will even look at using long multiplication. Let's begin by multiplying k minus 1 times negative 4k minus 1. Now the idea here is that we will multiply each term in the first polynomial by each term in the second polynomial. So if we think about this for a moment, we'll be multiplying the k by the two things in the other parentheses, and we'll be multiplying the negative 1 by the two things in the other parentheses. So that will be a total of 4 little multiplication problems. Now the box diagram will help us organize those 4 little multiplication problems. So when multiplying a binomial by a binomial, I'm going to have a spot here for k minus 1 across the top. And then along the left side, it'll be negative 4k minus 1. Now, instead of writing minus 1, I'm going to change that to plus negative 1, just so I don't miss that that's a negative 1 right there. All right, let's get started multiplying. Negative 4k times k is negative 4k squared. Negative 4k times negative 1 is positive 4k. Negative 1 times k is negative 1k. And finally, negative 1 times negative 1 equals positive 1. All right, looking at my 4 products inside the diagram here, I notice that I have some like terms, negative 1k and 4k. Well, we are going to combine those like terms, negative 1k plus 4k. Remember, when we combine like terms, we're adding, but since the signs are different, we subtract in this case. So we get 3k, because negative 1k plus 4k equals 3k. All right, we're all set to write our answer now. So I look at what I have inside the box diagram. I have my k squareds, and I have my k's, and I have my constant term. So the product is negative 4k squared plus 3k plus 1. Let's try another one. N plus 2 times 5n plus 4. Once again, we're multiplying two binomials, so we're going to have 4 little multiplication problems. So let's go ahead and we'll use a box diagram to organize those 4 multiplication problems. I'll write n plus 2 across the top and 5n plus 4 along the side. And let's multiply 5n times n, 5n times 2, 4 times n, and 4 times 2. Let's combine our like terms. 4n plus 10n. And now we can write the product. We have, so n plus 2 times 5n plus 4 equals 5n squared plus 14n plus 8. Let's continue using a box diagram for this multiplication problem, which is a little different. This time we have a binomial times a trinomial. Okay, so let's think about this for just a moment. We're multiplying each term in the first polynomial by each term in the second polynomial. So we'll be multiplying the 5v times these 3 terms and multiplying the negative 2 by those same 3 terms. That's 6 multiplication problems. So our box diagram will have 6 sections. Now, I like to have my trinomials across the top in a situation like this. So here's one way to set up our box diagram. All right, I'll write in this case, the second polynomial across the top, and the binomial along the side, I'm going to write that plus negative 2. All right, we have this box here for each of our 6 little multiplication problems here. All right, we have 5v times 3v squared, and then 5v times 5v, and 5v times negative 1. Along the bottom, negative 2 times 3v squared, negative 2 times 5v, and negative 2 times negative 1. All right, let's look for any like terms we might have. All right, we have some v squareds. So negative 6v squared plus 25v squared, that will be 19v squared. And then we have negative 10v and a negative 5v. That's negative 15v. All right, well, we are ready to write the product of 5v minus 2 times 3v squared plus 5v minus 1. That equals 15v cubed plus 19v squared minus 15v plus 2. Okay, here's another one to try. 5n plus 1 times 3n squared plus 5n plus 2. I'm setting up my box. I know I'm going to have the trinomial across the top and the binomial across along the side. Five n times 3n squared, 5n times 5n, 5n times 2. 1 times 3n squared, 1 times 5n, and finally 1 times 2. I'll circle the like terms here. We have some n squareds, and we have some n's again. And our product is 15n cubed plus 28n squared plus 15n plus 2. Now, when we use the distributive property to multiply polynomials, we're doing the exact same thing. We are still going to multiply each term in the first polynomial by each term in the second polynomial. Some people call this FOIL, which stands for first. So we're multiplying the first terms, and the outside terms, then the inside terms, and finally the last terms. So notice we're just using the distributive property twice. All right, negative 4n times n. So that's negative 4n squared. Negative 4n times 2. Negative 8n. Negative 5 times n. And finally, negative 5 times 2. All right, so we have our 4 little products from our 4 little multiplication problems. Now we're going to combine our like terms and write our final answer. So we have negative 4n squared minus 13n minus 10. Now these are the same exact multiplication problems we would have done had we made a box diagram. It's just a different way of organizing our work. Let's try this next one. So we'll multiply 2v times both terms in the other parentheses, and we'll multiply the negative 3 by both terms in the other parentheses. 2v times 4v, 2v times 5, negative 3 times 4v, and negative 3 times 5. We notice we have some like terms, and we're ready to write the product of 2v minus 3 times 4v plus 5. That equals 8v squared minus 2v minus 15. We can use the same method when we multiply a binomial by a trinomial, only this time it wouldn't make sense to call it FOIL, because that was for a binomial times a binomial. Same idea, we can distribute the n. So we'll multiply the n by all three terms in the other polynomial. And then we'll multiply the 3 by all three terms in the other polynomial. That will be 6 little multiplication problems. Let's get started. N times 3n squared. N times negative n. N times 3. 3 times 3n squared. 3 times negative n. 3 times 3. Let's look for our like terms. We notice we have two terms with n squareds, and we have two terms with n. All right, let's write our final product. So we have 3n to the third power. Combining our like terms, that makes 8n squared. We understand there's a 1 here. So it's negative 1n squared plus 9n squared, which is 8n squared. And then 3n minus 3n, well, those cancel each other out because they're opposites. And then the plus 9 tags along. All right, so we found the product of that binomial multiplied by the trinomial. Let's try another one like this. So we have 2x plus 3 times 3x squared minus 3x plus 1. We multiply the 2x by all three of the terms in the other polynomial. And we multiply the 3 by all three terms in the other polynomial. 2x times 3x squared. 2x times negative 3x. 2x times 1. 3 times 3x squared. 3 times negative 3x. And 3 times 1. Let's look for like terms. We have some x squareds. And we have some x's. And for our final product, we have 6x cubed. See, negative 6x squared plus 9x squared is 3x squared. 2x minus 9x is negative 7x. And the 3 tags along. Now, another method you might like using when multiplying a binomial by a trinomial, or an even longer multiplication problem, is what we refer to as long multiplication. Now here we're multiplying negative 4x minus 2 times this trinomial. All right, now remember, I'm going to have 6 little multiplication problems because I'll be multiplying the negative 4x by all three of these other terms and negative 2 by all three of the terms in the other polynomial. Well, from long multiplication, you can set up one of your polynomials underneath the other. In this case, the binomial underneath the trinomial. Now I'm going to multiply each of the three terms in the trinomial by the negative 2. All right, so I have negative 2 times 7, and then negative 2 times negative 8x, and then negative 2 times negative x squared. So this method is just a different way of organizing our 6 multiplication problems. I have 3 more to go. Now I'm going to multiply each of the three terms in the trinomial by negative 4x. And while I do that, I'm going to be lining up my like terms. So negative 4x times 7. Negative 28x. I'm going to line it up with the other x's. Negative 4x times negative 8x. Positive 32x squared. And then negative 4x times negative x squared is positive 4x cubed. All right, I have some like terms to combine, but we're just going to think of this now as like an adding problem. So first we multiplied everything in the trinomial by negative 2. Then we multiplied everything in the trinomial by negative 4x. Those are on 2 separate rows. And now we're going to add those rows. And while we do that, we'll be combining our like terms. So we have the 4x cubed And we have these x squareds here, so that's 34x squared. And then we have 16x minus 28x, so that'll be negative 12x. And the negative 14 just tags along. And there's our product. And here's one more to try. So I'm going to line up my binomial underneath a trinomial and multiply. I'm going to start by multiplying each term in the trinomial by 1. So it'll be a negative 6, a negative 4v, and a 3v squared. So I just multiplied everything in the trinomial by 1. Now I'm going to multiply everything in the trinomial by 5v. So I'll have 3 more little multiplication problems, and I'm going to be careful to line up my like terms. So 5v times negative 6. 5v times negative 4v. 5v times 3v squared. Now when I add the two rows, I'm just combining like terms. So we have 15v cubed minus 17v squared minus 34v minus 6. In this video, we use 3 different methods of multiplying polynomials. We made box diagrams, we used the distributive property, and we even used long multiplication. Now, unless you're told to choose one of those in particular, you can use whichever one you like best. Hopefully this video has been helpful. This is Mr. Ela, signing off.